1990 is 100mm concrete block.
Okay, so what we're going to look at is our U value question from 2019. So, question reads, the external wall of a house built in 1990 is 100mm concrete block construction with a 100mm partially filled cavity is shown. Part A of the question is calculate the U value of the wall given the construction that has the following sequence of data. So I'm just going to read out all our materials. So we've external render, concrete block outer leaf, clear cavity, polystyrene insulation, concrete block inner leaf and internal plaster. They all have different thicknesses, you can see them all there in the question. If you look at the thermal data for the external wall, you have the external data for all those items, but you also have the resistance of the internal surface and the resistance of the external surface. So please ensure that you include these as well. Okay. So the first thing we do when we get this question is we draw out what we have. Okay. So we're going to have, the first thing we have is our external render. Just do a small sketch, it doesn't have to be anything great. And we have our concrete block as well. So first thin layer there is our external render, concrete block. Next we have a clear cavity. We have our polystyrene insulation, and we have concrete block inner leaf and internal plaster. Okay, so this is our insulation. Put in our symbol for it. Okay, this is our external. This is our internal. We already have the resistance for those, so we can put those in when we're filling in our grid. Okay, we'll just make those look a bit more like concrete blocks. Okay, so that's all our detail. So we'll tick off each item as we have it. Okay. So our first item that we can go to is our external surface. Okay, so we put that in our element. Okay, we don't need to fill in anything here, we go straight to resistance and 0.048. Alright, we're given that in the question. Our next one is our external render. We don't have the conductivity, but we do have the resistivity. It has 2.171. The thickness then of it, remember you have to get this in meters, so it's 0.016. In the question it gives us 16 millimeters, but in meters it's 0.016, so make sure you get that. Okay. Now our formulas. Okay, so when we have the resistivity, it's going to be T by R, the small r, and if we have the conductivity, it's going to be T over K. Alright, so there are two formulas that we need to calculate our resistance. Okay, so when we put in the formula for T by R, we multiply this by this, we're going to get 0.035. Okay, next thing we have our external block work. We have conductivity for that of 1.44, and we have a thickness of 0.1 or 100 millimeters as given in the question, but again make sure you convert it into meters. The resistance of that should be 0.069. We have our cavity then. Again, we don't have anything for that here, so we're going to go to our resistance straight away, and it's 0.170. Our insulation, going to be that gives us a conductivity of 0.037. Again, formula that we're going to use is T over K, so our thickness for the insulation is 0.05. So T 0.05 over 0.037 will give us 1.351. We then have our internal block work. And that gives us, internal block work is 1.44 again. And our thickness again is 0.1, and it's going to be the exact same as the external block work, so it's 0.069. Then our internal plaster, and that is, for this we have the resistivity, which is 6.25, and the thickness is 12 millimeters, so it's 0.012. So our resistance then for that, when we put it as T multiplied by R, so it's 0.012 multiplied by 6.25, it's going to give us 0.075. Now, last one, so if we look at it, we have the external done, we have to render, external block, cavity, insulation, internal block, internal plaster. We have to do our internal surface as well. Okay. So our internal surface, we're actually just given the resistance of this. So it's 0.122. Now, we haven't got our U value yet, so to get our U value we have to add all those values and we have to divide them. Okay, so we're going to put 1 divided by our R total. Okay, so I'm just going to zoom in here as well. Sorry, I wasn't looking at the camera. So we're going to add all those values up to get our R total. Okay, so resistance total equal to 1.939. So to get our U value, the formula for it is 1 divided by RT. RT here is our resistance total. So U value is to 1 over 1.939. Okay, that's going to give us a U value of 0.516 W slash M squared degrees Celsius. Okay, that's part A of the question answered. Okay, if you got something close to that, you'll get the marks as well. So just be sure when you're going to decimal place, go to the same decimal place every time. So for example, I went 3 decimal places here. If you went 4 for the first one or the second one, go 4 for all of them. Alright, just make sure that they're all the same. Because sometimes, even if you only go 3 digits for one and the rest 4, it can skew your result here for the U value. Okay, so that's something you don't really want. You want it in and around the value that they're given in the question. Okay, so if we move on to part B. Right, so part B of the question, it says, using the U value of the wall obtained in 5A above and the following data, calculate the cost of heat loss annually through this wall. The area of the external wall is 135 metres squared. The average internal temperature is 19 degrees. Average external temperature is 5 degrees. Heating period is 9 hours daily for 36 weeks per annum. Cost of oil is 94 cents per litre. Calorific value of oil is 37,350 kilojoules per litre, and 1000 watts equals 1 kilojoule per second. Okay, So to do this, there's a number of formulas we need to get. Right? Our first one is our heat loss formula. So this is equal to our U value multiplied by our area multiplied by our temperature difference. Now, for our U value, we're going to use the U value we got in part A. So it's 0.516. Our area is given to us in the question as 135 metres. For the temperature difference, it gives us the external temperature and the internal temperature. So we take the external temperature away from the internal temperature to get the temperature difference. So it's 19 for internal, take away 5 for external. Okay, when we multiply all those out, so again it's going to be 0.516 by 135 multiplied by 14. Okay, so that's going to give us 975.24 watts. Right? That's the amount of heat we're losing through the wall. Okay. Next, what we need to calculate is our heating period. Alright, it actually gives us a heating period, but we need to convert it into seconds. Alright. So for this, the heating period they give us is 9 hours daily for 36 weeks per year. Right, so the first thing we're going to do is we're going to convert the hours to minutes. So to convert the hours to minutes, we're going to multiply 9 by 60 to get them into minutes, and then we're going to get them into seconds, so multiply it again to get it into seconds. So we have our heating period. So we're heating it for 9 hours. We need to convert that to minutes, multiplied by 60. And we need to convert that into seconds multiplied by 60 again. We then look at the amount of days we have and the amount of weeks we have in the year. So it tells us it's daily for 36 weeks. So daily is going to be, obviously there's 7 days in the week, and it's for 36 weeks in the year. That will give us a total of 8,164,800 seconds. Okay. Now, the next thing we need to work out is the amount of kilojoules we're using per year. Okay, so we have the amount of time and we have the heat loss as well there. 2 seconds there now to answer the door. Okay, sorry about that. So getting back to this, we have our heat loss, we have our heating period. Next we need to figure out how many kilojoules we're using per year. So to do this, what we're going to do is we're going to put the amount of heat loss we have, multiply it by our heating period, and divide it by 1,000. So it's going to be 164. So again, it's our total here over 1,000, which gives us kilojoules per second. Okay. Now, That's important we get that because we need that for the amount of litres we're going to use of oil. Okay, so let's go to the next page. Okay, so our litres per year. Right, so to do that, we get our total kilojoules from our previous page we had, and we're going to put that over the calorific value of oil. Right, so it's by the calorific value of oil is given to us in the question as 37350. So that comes out as 212.34 litres. Okay. Now, this question asks us to calculate the cost of oil per year. Right. So it told us in the question 1 litre is equal to 0.94, so 94 cents. Okay. So if we just multiply 212.34 by 0.94, it's going to give us €199.60. Okay, so the cost of heat loss annually is €199.60. Okay, again, this might change depending on what U value you have here. Every other number is given to you in the question. The other place that people fall down is the heating period here. Okay, so you need to make sure that you get that in seconds. Right? So again, it's 9 hours multiplied by 60 to get it into minutes. Multiply it by 60 again to get into seconds. We have 7 days of the week and we have 36 weeks of the year, and that will give us that answer there in seconds. Okay, all the other formulas or all the other digits are given to us in the questions. Okay, so that's the only bit of figuring out we really need. Okay, now if we look at part C, this is the part that sometimes people don't answer, or they just maybe don't have time, or they find it a bit more difficult because they don't focus on it as much. Okay, so part C is it is proposed to upgrade the thermal properties of the above wall to meet the passive house standards by fixing extended polystyrene to the external surface as shown. Given the thermal conductivity K of extended polystyrene is 0.031, calculate the thickness of extended polystyrene required to achieve a U value of 0.15. Okay, so for this we're going to use some of the information we have already. Right? So what we need to do is we need to get the resistance total that we have in our wall. We already have that from the previous question. Okay, so it is 1.939. Okay, so I'm just going to write this out for you. So our current U value is 0.516. So our current resistance is 1.939. Again, we have that information from our previous part of the question. Okay, from our part A of the question, we have our total resistance. Okay, so what we need to do next is we need to figure out the resistance we need to get the U value at 0.15. Okay, so resistance required for U value of 0.15. Okay, now how do we get that? Right, so what we're going to do is we're going to use the formula we had to get our U value in part A of the question. Okay, so our formula was R equals 1 over U value. Okay, so what we have in the information we have to answer this is we have our U value to get R. Okay, So this is equal to R equals 1 over 0.15. Okay, so when we do that, we're going to get 6.666 meters squared. So that's W. Okay, so R equals 6.666. Okay. Now, we already have some insulation in the wall, and we already have a certain amount of resistance, right? So what we're going to do is we're going to take away this resistance from our new resistance. Okay. So our new resistance minus old resistance will give us the required resistance. Now the question is asking for the thickness of polystyrene, but you need the resistance to get that. Okay, so it's 6.666, take away 1.939. That's going to give us 4.727 meters squared K/W. Okay. Now we're going to come back here to our formulas again to get the thickness. Okay, so to get the so if we have, we'll say, the conductivity and the thickness, we can get the resistance. So for this question, we have the resistance and we have the conductivity that they give us in the question. So in part C, they say the conductivity of the polystyrene is 0.031. Right, so we're going to use that to answer this question. Okay, so we're going to use the formula R equals T over K. Okay, so we have R, we need T, and we have K. Because K is given to us in the question again in part C, it's 0.031. Okay, so our formula, if I was to write that out, it would be 4.727 equals T over 0.031. Okay, so we're going to use we're going to break that down then again. So T is going to be 4.727 multiplying it by 0.031, which is going to give us our thickness. Now, remember, when we were doing this question, all our thicknesses converted into meters. Okay, so it's going to give us the answer in meters. So it's 0.146537 meters. Okay, right. So that's what we need to achieve U value of 0.15. So 0.146537. If we were to convert that into millimeters, it'd be 147 millimeters of insulation. Okay, so that's what's needed for U value of, sorry, you can't see that, 0.15. Okay, I'm going to go over that again because I don't think you saw half that, right? Apologies. Okay, so the first thing we need is we need to get the resistance that we currently have. Okay, so our current resistance is 1.939, and then we need to get the resistance that is required for a U value of 0.15. So to get the resistance that is required, we're going to use our U value formula. So R equals 1 over the U value. So R equals 1 over 0.15, which is going to give us 6.666. Okay, so this is the resistance that we need to achieve a U value of 0.15. Now, if we take our new resistance, which is 6.666, and we take away 1.939, which is our old resistance that we have from part A in the question. We're going at 4.727 meters squared. Right? That is the resistance that we need to get the required U value. Now, we're going to use our formula again that we used in part A. Right? So resistance equals thickness over conductivity. Now, this is the resistance we require, 4.727. We don't have the thickness, we have the conductivity from the question. So part C tells us 0.031. So the thickness is 4.727 multiplied by 0.31, which is 146,537 meters. Remember, it's going to be meters because all of our calculations here, we have to convert everything to meters. So you can either leave it in meters or you can say it's 147 millimeters. Okay, sorry, no, you can't see that again. Okay, that's needed for a U value of 0.1.